Hello, everyone. So we have a algebra problem where we are gonna deal with. So whenever you have some expression that are equal to each other, so we can try plug in some values for the given unknowns like x, y, z, and k in this problem. That will make all three fractions to be equal to each other. And then based on the number that we have chosen, we can just replace these into this fraction to get a number and then see which one of these choices will give us the same result as this. So you can try such a thing, but in that case, you might be finding a couple choices that will give us the same result. In that case, you want to change the number that you have chosen for those x, y, z's and t's. I mean, yeah, all of those variable, and then get another like number for this fraction and see which one of those choices actually work in your first try, don't work in this case. And then until you eliminate all the choices, then you can continue in that process, which is still okay to try as long as you're not too slow. I guess we can still handle that. But instead of doing that last result, I'm going to try something else. Like we have a fraction divided by x. So let's rewrite this as like 3x over x plus y over x. And that is equal to 3z plus 3z over z plus t over z. And that is equal to 1 over k. So if I cancel the x's, so you will get 3 plus y over x, and that is equal to the z's will cancel, 3 plus t over z, and that is 1 over k. So this is kind of okay, better than what we have, but still, it's not really that useful either. So I have 3's on like these two parts. Maybe I can subtract 3 from both, like all sides of the equation. So if I subtract 3 from this guy, so you will get y over x is equal to t over z if you subtract 3, and that will give us 1 over k minus 3. Like the reason I just did this way, because the expression we are looking for is y plus t and x plus z. Like we like to get y and t and x plus z somehow. So which is why anything other than those variables, I like to make them on one side, okay? So, but how this is going to be helpful. So at this point, I'll just remind something that if you don't know, we can try to kind of remember as well. So whenever you have a fraction, let's say a1 divided by a2, if this is equal to b1 divided by b2, let's say this is equal to c1 divided by c2, and if there is a bunch of like fractions that is equal to, let's say, I don't know, x 1 over x2, it doesn't have to be those variables. Let's say this is equal to a fraction, a number. What the k could be number like fraction as well. So whenever you have a bunch of fractions that are equal to each other, we even add the numerator. We even can add the numerator, and then we get the same result as these ones. Okay, so what I mean by that, let's say if I add a1 and b1, okay, and then if I just add a2 and b2, and this fraction is going to be equal to all of these fractions as well. And if I want to add 3 of those, which is also ka1, like b1, c1, all this divided by like b1, I guess, a1, b1, okay, b2, and actually a2, right? So I'm not sure why I'm doing this, but let's see. So this is going to be a2, B2 and C2. And you may do this for any number of terms, and you may even like multiply the fraction by some like constant and then add or subtract those, and then you get the same result as well. So, and then this is something you can try to prove it, but for now, I will just remind and move on, okay? So why this is important? Because if you add the y and t, and then if you add the x and z, this is something what we are looking. So let's simplify this as well. If I add the numerator, so you will get y and t, okay, y plus t over x plus z. So this is equal to this right side, which is 1. I can multiply this by k to make the common denominator. So that will be 1 minus 3k over k. So now we have something, but we like to find the reciprocal of this guy because that's what we are looking for. So that should be reciprocal of this guy as well. So that is the choice A. So that is something we can do. And if you didn't really know about this one, I will say you can review those questions, maybe do more problems on your own just to get better. But this is good of properties of the ratios, okay? So let's look at another question. So the next question we have is a clock problem, so which is also common type. So the question was asking the angle measuring between the like minute hand and the hour hand when it's 10:10 a.m. Okay, so just remember, like if you like look at the number of like the whole thing is 360 degrees, right? And then we have 12 equal space, which means each of those will give us 30 degrees. So like if you move from 12 to 1, 1 to 2, so that will be just 30 degrees measure. And if you were like facing, as let's say our hand is facing towards 10, and then the minute hand towards like 10, so that will be like 4 of those, so like 30 degrees, which is 120, right? So that looks like the choice C. A lot of people are gonna do this choice C, but there's problem with this because when you were at 10, exactly at 10 a.m., so if the time is like 10 a.m. or 10 p.m., so the hour hand is actually facing to 10 like right now, but the minute hand is gonna face towards the 12 when the 10 a.m. or 10 p.m. But when if this is 10:10, which means the minute hand is not actually facing towards like 12, if this moves like 10 minutes this way, the hour hand is gonna move from this direction to this 11 a bit. Okay, so if this was the original one, so let's say this is the original hour hand when the time is 10 a.m., then it will move a bit to the this way. So instead of 120, then we should have a bit lesser than that. So you can immediately cross these choices. And if you cannot find exactly which one does look like, maybe you can guess on one of these choices. But I feel like this is gonna be the good one because it's not gonna be too much difference of 120 and what we are looking, but let's find the actual value. So if you were like moving this minute hand all the way an hour, which is a 60 minutes, then the hour hand will move from 10 to 11, which is when you move this minute hand 12 of those like equal spaces, this will be only moving only one of these equal 12 spaces, which is 1/12 is the speed of the hour hand, right? So if this is gonna move like only 12 to 2, which is that's 2 out of 12, which is 1/6 of the whole, I guess, rotation when you have 1 hour. So 1/6 of the movement from our hand from 10 to 11 is just 30 degrees. So we are going to find the 1/6 of that 30 degrees for the hour hand that will move on. So that should be 5 degrees. So I hope that makes sense. We mean that the hour hand is going to move 5 degrees to this direction. So which means the 120 will decrease by 5 degrees. So that should be choice B. So that is, I guess, not too complicated. And if you do need a bit more practice of the clock problems, I will attach a few more videos in the description so you can review those as well. Okay, so let's try next one. So we have now a geometry problem. So before we try this problem, I just kind of need to remind a couple properties. So when you have two lines are parallel, so let's assume these two lines are parallel, and then the third line passing through that two parallel lines. So if these two are parallel, the angle right here and the angle right here, which is on the opposite side of the third line, are congruent, meaning they are equal measure. And then we have a name for these two angles that's called alternate interior. So for that reason, if you look at the KA and BD, they are also parallel. We are told that's the case. So meaning that this 25 should be same as this 25. And then some people make a Z, so the angle in between those like corners on that Z is gonna be equal to each other. So you can just make a Z like that. And if this is 25, since we are told these three are equal, so that is also 25 and 25. And also we know some other angle types that is also good to remember is just the corresponding angles. If you look at this example, so the angle on the, let's assume this one. So And then this is to the right of this third line, and it's inside of this line, like I mean to the lower than this line. And if you look at the another line, and if you go lower than that, that is also to the right of the third line. These two angles are in the same position. We call them their corresponding angles. And also like this angle and this angle is also corresponding angles. And we have a lot of other corresponding angles, okay? So for that reason, we can say the angle right here and the angle right here are equal to each other. So which we are gonna use in a second. But also we have some other properties as well for the angles. For example, if you have the two lines again parallel, and if you draw two segments that is intersect at some point like this, the angle right here, let's say this is alpha, and let's say this is beta. And if I want to find the angle in this vertex, but inside, then I can do some sort of like the third line. I can draw another line that passes through that intersection that is also parallel to the other two lines. If these three lines are parallel, the angle alpha and the alpha ray, this angle right here should be equal, because that's also alternate interior angle, same as the first reasoning. And since this is parallel to this one, so this is beta, then this is also beta. So meaning that the angle that facing this direction and facing this direction, when you have some sort of zigzag, the sum is equal to each other. So meaning that if you look at the angle A, like these three angles, that is 75, facing those together to the left side, if you kind of don't see it, so you can just make a new figure. I'm just explaining, but for those people who actually know this, that will make it a bit faster. So I will go with like drawing the figure. So like the angle right here is Y, is facing this way. And then if you use the similar reasoning, this angle, this plus this angle is going to be equal to Y. So we know this is 75. 75 plus the angle D should be the Y. So that means this part should be Y minus 75. Again, you don't have to memorize such a rule, but it's good to draw some additional lines to make our life a bit easier. And because of the corresponding angle that we mentioned right here, so this angle has to be same as angle C as well. So that is also Y minus 75, because EC and YD, I mean FT is parallel. So that's also another thing we were given. And the last thing I'm gonna just remind, which we can prove as well, whenever you have a like convex figure like this, which is a quadrilateral, right? I mean concave, the angle inside like 25. So let me like 25, this 25, and the angle right here. When you add those three angles inside of this concave like figure, is actually equal to angle outside that is in the concave region. So if you are wondering why that's the case, like there are a couple of ways to show why that's the case, but let me write that first. So you will get 25 plus 25 plus Y minus 75, and that is equal to X, okay? And we want to find the X in terms of Y, so which is what we have now. So we have the Y, and then that's 50 minus 20, 75, so which will give us my minus 25. So it looks like we have the choice B. Okay, so but here's the reason why that relation does work in general, because like one of the important features of the angles that we kind of need to remember is the exterior angles. If I extend this guy in a way that will touch the BD at some point, so the angle 25 and angle 25, two interior angles in AB, let's say this T, and when you add these two, that should be equal to this one. And then if you are wondering why, because this angle right here plus this angle is 180, the sum of these two plus this angle is also 180, so which is why this is common for those two. So the sum of these two, 25, has to be same as this one. So you will get this is going to be 20. And if you use the similar reasoning, the 50 right here plus the C, these are the two interior of this triangle. So these two plus the angle right here is 180, but X plus this angle is also 180. So that means X should be sum of these two angles. So we know this was sum of the other two, then these two is going to be X. So we can make that in general. So whenever you have a concave figure like that. So that will give us the sum of the inside angles. Let's say something like this, okay? If I have such a figure, so it doesn't have to be exactly this way, but it just gives us some idea. So let's say this is C. So the alpha, let's say this is beta, and then this is the, I'm gonna call theta. When you add those three angles, this is gonna be equal to this angle. So with this problem, we actually kind of review at least 3-4 features of the angles. So I hope that was clear. So that was the answer, choice B, okay? So let's look at another problem. So what we have now is a number theory problem. So the greatest common factor of 27 and another number is 9. So how many two digits? So let's highlight this part of M satisfy this condition. So the GCF or GCD, I'm gonna use GCD, of 27 and M is 9. So which means the M should be a multiple of a 9. Okay, so then since we are looking for a two-digit number, so we don't have too many. So if you start with like 9, multiple of 9s, so you will get 9, 18, like 27, like 36, 45, and 54, 63, 72, 81, 90, and 91. So of these, we just want to see how many of those will satisfy this condition. So the GCD, the greatest common divisor of two numbers, is 9. So if I choose the other number that is like 27 as well, GCD is not going to be 9. So you can immediately cross this one. But the question is, should I just check every single number like that? I can if I want to, because this is 7 points, so I can try that. But let's think about it a bit differently. You know, we have the GCD of two numbers is 9. So if they are like GCD is 9, so we know that the M should be like a multiple of 9 for sure. Okay, I'm gonna say 3 to the some power times maybe something else. Okay, we are gonna multiply by something. But if the power x is 2, that will be 9. But if I have this power to be 3 or 4, then the GCD will not be 9. It will be maybe 27, maybe something else. So which is why, you know, for us to get the GCD to be like 9, so we should have only 2 3's, which means this has to be 3 squared. So that's 9. But I need to multiply that by something. But if this number has a 3, that will make this product to be like 27 or multiple of 27. That will make the GCD to be different numbers. So I hope that reason is clear. So which means we cannot take any number that is multiple of 27. So 54 doesn't work, 81 doesn't work, because if I take the 27 and the like 54, then you are gonna get something else as well. Okay, so you're gonna get like either 27. Yeah, you are gonna get 27 as the GCD, which doesn't work. So anything that doesn't have a common divisor of 3, then we should be fine. So if I take the 18, for example, the GCD of 18 and 27 is 9, which does work. And if I take this one, that's 4 times 9, that does also work. And as long as the number that doesn't have any other like factor of 3, then we should be all good. So we have 1, 2, 3, 4, 5, 6, 7, 8. So it looks like we have 8 of them, right? But the problem with this, which I intentionally placed the first multiple of 9 right here, because a lot of people are doing this kind of stuff and then kind of get the correct reasoning, but at the end choosing the choice B, which is not our answer, because we have to get a two-digit number M. So which is why we should cross this as well. So we have only 7 number that does work. So for that reason, I highly recommend to kind of highlight some of the key points of the problem. So this was one of those tricks as well. So let's do one more. Okay, so the last question is a combinatorics problem. So we are gonna use these 1, 2, 3, 4, 6, and 8. And if no digit is repeated, and we like to get the product of 2 of those two, is equal to the product of the other two. Like, it's not too challenging, but let's try to organize our counting. So I can just multiply 1 by 2, that will be 2, but I don't have any other ways to get 2 with using the remaining digit. So 1, 2 doesn't work. Like, if I start with 1, 3, that doesn't work. 1, 4, that's 4, but there is no way other way. 1, 6, maybe. So if I choose 1 and 6, that's 6. So I can multiply 2 and 3. So that should be okay. But if I try 1 and 8, that is going to be 8, which I can do 2 and 4. Okay, so with 1, I try everything that is possible, right? So now I can try 2. If I choose 2 and 1, which already I try whenever I try all the options with 1, so which is why I don't want to do anything that is smaller than 2. So 2, 3 is like 6, but we already tried that. 2, 4, we try. 2, 6, maybe I should try, which is 12. So I can go with 3 and 4. And 2, 8 is 16, but there is no other way to get 16, so we cannot do anything with that. So now it's 3. So I can try 3, 4, which is 12, but I try already. And then 3, 6 is 18, but there is no other way to get 18, so that doesn't work. And 3 and 8, which is 24, I can go with 4 and 6. And I think we are done with all the choices, because if I try like 4, 6, which we already try, and 4, 8, that's 32, but there's nothing with that. And then 6 and 8, 48, but there's no way to get the other way. So we have 4, I would say, different ways to get the two sides of the equation are equal to each other. But the question is now, how many ways can we arrange these? Like, let's take the first example, like first case. If I want to do like 1, 6, 2, 3, that is okay. But I can do this 1, 6, and 3, and 2, right? Or I can swap the 1 and 2. So I mean 1 and 6, I can do 1, 6, 1, and 2, 3, or 6, 1, 3, 2. So as you see, we have 4 different ways to arrange it. And then that will be the case with this, with this, with this. 4 times 4 looks A, which is one of the choices. But the problem with them, this is not the only way. Like, I can say, like, this is my, let's say, K, L, M, N, right? So like, if this is the case, I can actually swap these, because if I swap these, what I mean by that, I can take the 2 and 3 to the first 2 digits, and then 1 and 6 to the last 2 digits. So I can do this 2, 3, 1, 6, 2, 3, 6, 1, or 3, 2, 1, 6, and 3, 2, 6, 1. So there are 4 different ways that I can start with this, and then these are going to be also satisfying this condition. And KLMN will be now a different number than the previous one, which means every time we have 8 different ways to achieve this restriction for each cases. So this has 8 ways to end this, and then 8 ways, 8 ways, 8 times 4 is actually 32. So this was a tricky problem, I guess. So that was the answer. And I hope that will make sense. We did like a few questions that was a bit challenging for this grade level, especially. But I'll see you in the next video, okay?